Okay, today I'm doing a demonstration how I designed a belt type oil skimmer in Fusion 360. Video playback speed has been sped up in the interest of saving time. So let's get started. So to start this belt type oil skimmer, I'm going to start with my gear motor. I'm going to bring in a gear motor SAT file from McMaster-Carr. And just a quick disclaimer, this video is not a paid promotion for McMaster-Carr or Autodesk or Fusion 360. These are just products I use for my work. So there's our gear motor, 120 volt AC. Took a measurement of the diameter of that shaft. I'm going to create the steel enclosure that the gear motor will be housed inside of. Use the extrude feature command in all steel construction. It's basically going to be a little metal box. For now, I want to make it clear so I can move the gear motor exactly where I want it and see inside the box. Need to leave room for my on-off switch, my strain relief. Want to keep the wires obviously away from the little cooling fan. I'll go down to metal, under the render tab, steel. And now using the shell command, we've turned it into a shell or a box. Woo! This gear motor is face mounted, so it will mount to that front wall or back wall of that metal box. It's creating an opening for the shaft to stick through. Okay. Again, trying to get it located where I want it. I'm going to do a sketch on this face and create some through holes that the mounting screws will go through. That will actually mount the gear motor to this metal housing. There we go. And I want to create an access cover on this back side. So I'm going to bring in some square nuts, and the square nuts will get spot welded to each corner inside of the metal housing, and that will allow bolts to bolt the access cover to the housing. So there's our square nut. I'll get it placed about where I want it. And again, that'll get tack welded or spot welded to that metal housing on the inside there. And then I'll simply copy it because I need a total of 4 of these square nuts. There we go. You can see I installed them recessed 1/8 of an inch to accommodate or allow for the cover plate. Now we'll extrude out a cover plate. And make sure I say new body. Okay, 1/8 of an inch thick. And that looks good. Now we'll hide that body that we just made. And in the render tab, I'm going to add some color to our gear motor. And to the housing, we'll paint it blue. There we go. Now I want to add our cord, our power cord strain relief. Great thing about McMaster-Carr, or there's other libraries where you can bring in 3D files so you don't have to 3D model every nut, bolt, screw, washer, etc. It's a huge time saver. So there's our strain relief for the power cord. Just kind of placing it where I want it. I think I'm happy with that. It leaves room for the cord to safely come in the box. We'll paint it black. I want to bring in the on-off toggle switch. And I'll just place this toggle switch where I want it to go on the side of the unit. Again, making sure I leave room for the wires inside. That looks good. Tighten our mounting nut down. There we go. In the render tab, I'll paint the body of the switch black. We'll paint the terminals copper. Chrome plating for the switch and nut. So I'm going to look through their pulleys and see if I can find one that has the right dimensions for what I'm looking for. If not, I'll simply make my own pulley. So in the sketch, I'm going to go ahead and create a circle. This will be the inner diameter of the pulley. Making a second circle, this will be the outer diameter of the pulley. Finish sketch. Click extrude. We'll extrude it out to the width that I want. I'll need to create obviously some raised shoulders or flanges on both sides so the belt stays on track. So I'll create another sketch on that face and create that flange, extrude, new body. I'll simply copy that and move the copy over for the other side of the pulley, like that. I think I'm going to adjust the sketch, go from 2 inch to 1.75 inches. Yeah, that looks better. I'm happy with that. I'm going to construct a tangent plane, and I'm going to create the spikes on this drive pulley that will engage the perforated belt. So the reason I'm creating a spiked drive pulley and a perforated belt is when the belt is covered in oil, it's going to be slippery, and I want a good way to securely grab that belt and pull it around the drive pulley. Thought about a round nub like this. That's another option, but I think I'm going to go with the spike idea instead. So I'm going to create another offset plane from that circle and then create a tiny circle which will be the top point of the spike. Then we'll use the loft command. We'll select our 2 circles and it creates that new body for us. There we go. going to select the body, get it centered where I want it. And then I'll simply create a pattern with this one spike around the entire drive wheel. So pattern, pattern on path, select the body, select the path. I think that'll be too many spikes. And I need to select path direction. There we go. So they're properly orientated. I think I'm just going to go with 4 spikes. Yeah, I'm happy with that. So that will engage our perforated belt. And our belt will be made from an oleophilic material, which means it attracts oil. The oil will stick to it, saving our work as we go. I'm gonna move that drive pulley in a little bit closer. Yep. I could extrude that drive shaft out, but I don't think I'm going to do that. I'm going to keep it stock, and I'll simply bring in a set screw that will engage that flat spot on the drive shaft. Yeah, that's what I'll do. I won't extrude that, because again, I'm trying to keep everything as stock as possible. Go up to insert. I'm just taking a measurement. So yeah, insert from McMaster Carr, a set screw, cup point set screw. Go with a small one, stainless steel. This is for demonstration purposes, so I'm not going to waste your time creating a new hole in this drive pulley. I think you get the idea. Set screw holds the drive pulley to the drive shaft. There we go. Rotating those spikes around to allow room to access that set screw. There you go. Now you can access that set screw. Now I'm simply making a copy, moving the copy down. So we just created our idler pulley. The idler pulley will sit inside the body of water, and it does not need spikes. I think I'm going to paint these pulleys yellow so they pop on the screen more, make them more visible. Looking for some bolts. So I'm just adding the mounting bolts that will bolt that rear cover plate to the body. And then same thing, I'll create a copy of that one bolt. So we have a bolt on all 4 corners. Again, just simply using the move command, selecting copy. Looks good. create a sketch on this back plate and remove some material because I want to have a vent, because this motor will get hot if we do not have a vent. So we need to allow this cooling fan to spin, allow the motor to breathe. So then I'll simply cut material. There we go. And then I'll add some fins on this face. I'll create one fin, extrude it out. Say new body. And then I'll rotate it about 15 or 20 degrees, place it where I want it. And then I'll create a pattern of that one fin all the way down once I'm happy with this one. I want to make it a little bit thinner. Yeah, that's better. Position it where I want it so we get good airflow. A little bit more of an angle. So the idea is you want to keep rainwater out of the unit, but still allow it to breathe. You can see I'm just using rectangular pattern. Select 5 for quantity. I'm happy with that. So in render, we'll paint that grill or that vent or those louvers blue. Okay. And then I'm going to make a sketch on this other side and extrude out some 1.5" square tubing that will be welded to the box. And this will be the actual mounting leg for the unit. Then we'll do a sketch and create a gusset in this corner for structural integrity. I'll create another sketch and we'll cut out that material. There's our gusset. Now on this bottom of the leg, I'll create a mounting foot or mounting plate at 1/4 inch steel. Yep. And then we'll paint everything blue and render. I think I'm happy with that. I'm going to find some countersink stainless steel screws that will actually attach that gear motor to the metal housing. There we go. Now I'll simply select that component, make a copy, move it over for that other hole. You get the idea. Now we'll create a sketch on that mounting plate using construction lines, and then we'll remove material or drill our holes for our concrete anchors to go through. There's our 4 mounting holes. Use the extrude command, cut. There we go. Creating a plane. And then create a sketch on that plane. And this sketch will become our actual perforated belt. The program's running a little slow. So the way I'll create the belt is I'll create a circle at the drive pulley and then a circle at the idler pulley, and then I'll connect the 2 circles with straight lines, and then I'll remove or cut the lines that I don't want. So it's going to be like a big oval shape, if you will. And for some reason at this moment, the program is running a little bit slow. It's a cloud-based program. There we go. Now I'll extrude that out. And that's going to be our belt. You can see I got the belt a little bit too small. So I need to make those circles slightly bigger. Can't wait for it to catch up. There we go. Again, draw my two lines down to connect my two arcs. Let's remove the material I don't need. Finish sketch. Use the extrude command. Say new body. Yep, that looks perfect. Then we'll use the, we'll hide the items we don't want to interfering, and then we'll use the shell command. There we go. So that's going to be our belt. Move the belt out of the way, and I'm going to cut out that back section. So now we have an actual belt. Now the belt can be made of stainless steel, polypropylene, polyethylene, etc. It needs to be an oleophilic material that oil will stick to. And create a tangent plane off of that drive pulley. What I want to do is punch holes in the belt now to make it an actual perforated belt. So I'll hide that cone or that spike. We'll extrude out, and there's our hole. So you can see how that works now. I'm going to pattern that hole around the entire perimeter of the belt. Just want to take some measurements to see what that distance is between the two spikes. And from there I'll create a sketch on the side of the belt. Apply my measurement. Then I'll make a series of holes on one side of the belt, and then we'll use the extrude command, cut, to remove material to make the actual holes. And I'm using pattern to space out my holes evenly. That way our holes engage with the spikes on the drive pulley properly. So that bottom pulley, you can call that a idler pulley or a tensioner pulley. Maybe more accurate to call it a tensioner pulley because that's actually what it does. It provides a little bit of tension on the belt. We'll select all of our holes, click extrude, cut all the way through, and there's our perforated belt. Happy with that? Now I'm going to create a sketch on the bottom of the unit. And we're going to create the scrapers and the angle iron trough that will direct the oil that is scraped off the belt into a collection vessel. So again, extrude. I'm going to make it out of 1/2 inch square tubing, cut it in half to give me my 1/2 inch angle iron. Do a sketch, draw a line across diagonally, and cut out the material I don't want. And then we'll use the shell command to make it an actual piece of angle iron. That one was a little too big. There we go. Make it just slightly smaller. Again, shell command. There's our angle iron, and then we'll rotate that body around. There we go. Place it where I want it about. So the theory of operation here, as you probably figured out, as the belt slowly turns around, it picks up the oil off the surface of the water. The oil comes around the drive pulley, and the oil will get scraped off by the scrapers I'm making right now, and then the oil will run down those angle iron channels into a collection vessel, and then the process repeats itself. And the scrapers can be made out of a rubber or polypropylene, etc. The scrapers need to be close enough that they gently remove the oil off the surface of the belt, but not so tight that it damages the belt or causes the belt to bind. So again, I'm just trying to match the profile of the belt and the scraper. Place it where I want it. And the scraper would simply be screwed to the angle iron. And I'll just mirror that scraper. I'm happy with it. So there's a second scraper right there. Move it over where I want it to go. And then I think from these angle iron channels, I'll divert the flow of the collected oil into a piece of pipe, and then from the pipe into a collection vessel. And again, everything will be obviously welded together. Saving my work as I go. So now I'm going to extrude out a new body. This will be our pipe. And draw a line across it. I'm going to cut some material off, not all of it. And then we'll use the shell command. I'll extrude out that last little bit with the cut command. There we go. Oops, a little too much. There we go. So you can see the oil will be diverted into that pipe and then ultimately into a collection vessel. And so that piece of pipe and the angle iron troughs will be spot welded together. And then I want to angle them slightly down and away to facilitate the flow of oil. So you can see there's a slight angle to them now, slight pitch. Don't want it to be too extreme, just a tiny bit. Yep. That should work just fine. Just want to move this where I want it. That's better. The pipe's a little long. I'm going to remove some material. Now I want to insert a pipe elbow. And that will direct the flow of oil into our collection vessel. Get it orientated how I want it. And again, these will be welded together. Okay. Happy with that. We'll paint it yellow. So now we need to create a collection vessel, which essentially will be a 5-gallon bucket in this case. So again, extrude. Use the shell command. Okay. Place it about where I want it. Oops, I accidentally cut through my pipe there. I don't need to fix that. So just undo. There we go. Now I'm going to create the lid for the bucket because we obviously don't want rainwater or bugs or animals getting in the bucket. Extrude, and I'll bevel the bucket lid. And we'll place the bucket where we want it. We'll bring in a small short pipe nipple. Okay. And then we'll create a small hole for the pipe nipple to go through the lid. Or you could use a union or a bulkhead fitting, but for this demonstration, just a simple hole. Almost done. Next, I'm going to move these 4 bolts so they're flush. There we go. And now I want to create the yoke for the idler tensioner pulley down here. This will give the pulley something to mount to. Using the extrude command, move it where I want it, I can resize it. Looks better. need to remove material from the center to allow room for the pulley. So I'll create a sketch and make a rectangle. Then we'll use extrude, cut. There we go. I'll move it in place. It's a little bit too thick, so we'll use our extrude, cut on both sides. Perfect. Using the fillet command, I'm going to round these 4 corners like that. And then I think what I'll do is we'll make a sketch on the top of that yoke and extrude up our flat bar, because we now need to make the frame, the flat bar frame that connects this yoke to the bottom of that metal box. And we need to make it adjustable so you can adjust the tension on the belt. I'm drawing a rectangle. We'll extrude the rectangle up. There's our piece of flat bar. Okay. I want to rotate it. That's better. Somehow I lost my radius. There we go. I'm going to copy this piece of flat bar to make our second piece of flat bar. They'll be bolted together, and we'll slot one of the pieces of flat bar, again to give us that adjustability. First, I'll create a sketch on this piece of flat bar on the edge and extrude it out underneath the box, so it will be welded to the underside of the box. There we go. And then for additional structural integrity, we'll weld that piece of pipe to that flat bar. Add a radius to that corner. Paint it yellow. I think I might paint the pulleys red so they stand out more. All right. So I'll create a sketch. We'll turn off some bodies so we can see what we're doing. There we go. We'll create a sketch on this face of the flat bar, and that will be the sketch that is the slot. So again, basically 2 circles and then 2 lines connecting the 2 circles to make our slot. There we go. And then we'll cut out the lines we don't want, like so. So finish sketch, extrude. I don't want to go all the way through. Using the cut command, go through 1/4 inch, and there's our slot. Then we'll create another sketch on the other piece of flat bar to have through holes for the bolts to pass through. Then extrude, cut. There we go. Then we'll bring in some nuts and bolts to bolt them together. And I'm going to use lock nuts for this situation. And then I'll make my own large fender washers to go underneath the bolt heads. Extrude cut, make them a little bit thinner. There we go. Place it where I want it. Then I'll simply copy that fender washer, move the copy down. There we go. I'm going to add a little mounting pin or mounting axle for that idler tensioner pulley to attach it to the yoke. Yep. And we'll add our concrete anchors to mount this unit to the concrete pad. And I'll simply bring in one concrete anchor and then copy it 3 times. That works. So now I want to extrude a power cord and a plug. So make a sketch on that face, extrude it out, my circle, new body in both directions. We'll paint it black. And then I got to figure out how much of the power cord I want to show in this demonstration. So I'm creating an offset plane. So I'll draw a few lines and circles, and then we'll turn those into our power cord. And then under the Create, up in the menu there, just taking a measurement right quick. Okay. So we'll use that line that we just drew and create a pipe. And there's our power cord. We'll paint it black. And we'll rotate it around. Again, this is just a 3D representation of a power cord. But you get the idea how this works. Excuse me. I'm just kind of playing with the positioning or placement of the power cord. So when you see it in the isometric view, does it look nice? Yeah, I think that's a little bit too much. I think I'm going to simplify all this. And just go with a simple 90-degree bend. So again, constructing an offset plane. Create sketch on that plane. Same thing, draw a line. Oops, my line's crooked. Let me fix that. There we go. Then I'll create a circle to make my radius, and then cut away what I don't want. So there's an issue there I need to correct. Yep. Okay. Now we create pipe. Again, new body. There's our cord. Paint it black. Place it where I want it. And then we'll bring in a male cord cap. The actual plug, male plug, 515. Yeah, NEMA 515 plug. Place it where we want it. See how that looks? And I add some color to the plug, make it pop. Yep. I just want to extend that cord, make it just slightly longer. So we'll select that face, extrude. There we go. Yeah, that's better. Then we'll create a sketch on the side of the unit, and we'll add some text to represent a sticker or a decal that says oil skimmer. Then we'll use extrude. Extrude the letters out slightly to make them a new body. Then we'll place the letters where we want them. Then we'll add color. So under the render, paint them yellow. Okay. Then I think I'll create a sketch on the top of the bucket lid, and we'll label it used oil. So again, text. Oops. Type in used oil. Okay. And same thing, we'll extrude. And then under render, paint those yellow. Yep. That's about it for this demonstration today.
Wow.
I hope this tutorial helped. And one final look at our final product. Front view, back view. Please like, share, subscribe, leave me a comment, and thanks for watching.